Hello, everybody, and welcome to TGI Kubernetes. I am your host, Joe Beda. I'm a principal engineer at VMware. And for those who don't know, TGI Kubernetes is our mostly weekly YouTube live stream where I play around with all things Kubernetes and we learn a bunch of stuff together. And we are on episode, oh my goodness, 92 now. So we've been doing this for a while. So first of all, sound check. Do I sound good to everybody? Things working well? Awesome. So I like to actually, as we start these things, make sure I say hi to everybody in the chat. I love making this as interactive as possible. The with us as always is Lamadi. Good to see you, and Rory also from Scotland. Shahar, good to see you. Murat from Bangladesh. Duffy from our CAT team here at VMware. That stands for Kubernetes Architecture Team. Also, often a host of TGIK is joining us, at least for a little bit. Thanks for joining us, Duffy. Marco from Belgrade. So I can't figure out how to silence Slack here. So Slack is now causing me troubles. This is the problem. Usually I was able to silence it, but somehow that broke recently. Anyway, so you may hear Slack going off. I'll quit it if it causes too much annoyance. Let's see. We have somebody from Perth. It's 4 a.m. Wow, thank you for joining us. Let's say Marco, Steve, another VMware person. Thanks for joining us, Steve. Peishu, Jose, Sandeep, Payam from Milan, Saeed. Good to see you all. All right, so this is going to be an interesting episode. My plan this episode is I'm going to continue doing some live coding from some stuff that we did several weeks ago, essentially using KubeBuilder to build a Minecraft controller. Now, here's the dirty secret. I haven't been doing a lot of coding recently. So much of my job is essentially drawing boxes on a whiteboard or sort of the equivalent with Word and Google Docs and such, Confluent. So you're going to see me be rusty, which is, I think, part of the fun here. So somebody's telling me that I can go through and tell Slack to silence itself with a do not disturb thing. Let's see if we can figure that out. /DND. Now, I wonder if that does it across all of my workspaces. We'll see. We'll see how that goes. So, okay, cool. Let's see. And then Mohammed from Paris. Inislav from Bulgaria. So we're going to be doing a little bit of live coding using KubeBuilder to continue to build a Minecraft controller. With the idea here is that we'll have a resource definition that can define what type of Minecraft server you want, and then we'll launch that thing and we'll manage it. And I think there's some interesting issues over time that we can look at in terms of how do we manage state for this thing, because a Minecraft server is actually stateful. And so I think that starts to get interesting over time. And then we can also look at, how do we manage graceful shutdown of these things? Because it turns out that you can lose state with Minecraft servers if you don't actually gracefully shut them down. And then there's also interesting issues with respect to networking, because the Minecraft API is not HTTP. And so a lot of our standard patterns don't necessarily work there. We won't be able to get to all that today, I promise you, but at least that's the stuff that we're going down. Let me go ahead and get started here. One of the things that we like to do, and I'm going to switch to my screen, is review news of the week, what's been happening in the Kubernetes world. And so Duffy and George helped to pull some of these links together, which I think is great. So the first thing I'd like to do is announce that we have results for the Kubernetes Steering Committee. And the folks joining us is Chris Blecker. Derek Carr got reelected. He was a member of the steering committee, and he's continuing to be. Nikita from Lutzi. So she is a great story. Her and Lucas gave a great talk at KubeCon. You can find the YouTube link talking about their journey to joining Kubernetes. And so it's great to see Nikita actually, get involved to the point where she's now on the steering committee, which is awesome. And then Paris, who's been a long time member of the community, super involved in contributor experience and other stuff. It's great to see her get involved in the steering committee also. And then there's also the folks that we're saying goodbye to, and that includes me. So after we sort of make this stuff, I don't know when we're officially effective here, but I will no longer be a member of the steering committee, which I think, it makes me a little sad, but I also think it's absolutely awesome to see that we're seeing this community management. I mean, this is really what open governance looks like on an open source project. And to see like folks come together and really work for the good of the project. It's really exciting to see that happen. So this is really quite the milestone for, so now I'm still getting like Slack doing its thing on me here. I don't know what's going on. So this is really quite the milestone here for this stuff. So I'm gonna go ahead, give me like 3 seconds here. Is there a way I can tell Slack, mute me now, forever, and always? Stupid thing. I think part of it is that it ends up being a preference on a per workspace by per workspace basis. And so that ends up being a pain to actually get Slack to mute. So unless I can find something in the next 3 seconds, I'm just going to quit Slack. So I do have like Duffy and George sending me notes here, and that's why I want to keep it open. But I think instead we're just going to have to communicate over the comments here. So I'm going to quit Slack. Okay, cool. I did the option click on the top right. So I have notifications turned off, but I think there's something in maybe the Slack client where it actually ignores that now. So I think that might be what's going on. So anyway, so Duffy, tried to add the keynote to the chat, but then it squashes links there, and so it got added to the show notes. And so if the rest of you want to actually add something to the show notes, feel free to go ahead and do that. And then Lamatti's asking, TGIK episode 100 is right around KubeCon. So we're going to do a live TGIK type of thing at KubeCon. I don't think we're set up to do a live stream there. I mean, if you saw like, I think here, we're going to do an Inception type of thing here. If you saw like my setup here, I have like a huge monitor and my laptop, and I have the whole thing sort of set up to be able to broadcast. It's really hard to broadcast from just a laptop. And so I'd love to do something live there, but I think we'll probably have to plan something for episode 100 separately to be able to accelerate that and do a bunch of stuff. Okay, so let's see. Other news, I want to get through this fast. KubeVirt joins the CNCF. KubeVirt's a really interesting project, mostly being driven by Red Hat right now, which essentially is about running VMs inside of containers. So there's different ways that VM technology and container technology are mixing. This is a really interesting way of doing it. In some ways, this mirrors, I think, the way we built Compute Engine back in the day. There's also parallels between this and some of the work we're doing at VMware around Project Pacific, different sort of ways to skin the cat. So this is actually really interesting, and I think it's going to be interesting to look at this perhaps in the context of things like Ignite from Weaveworks, which is a sort of lightweight VM type of thing. So some really interesting stuff there. It's good to see that join the CNCF, I believe, at the sandbox level. We already have a 1.17 alpha. I think, this really, to me, is because we just finished 1.16, it feels like. But to me, this is an indication that we're starting to get a lot of the sort of release mechanics down so that we can actually sort of start the next release cycle as soon as we finish the previous one. Great talk here from the name of the person was Kenta Iso. On sort of inside of a Kubernetes controller. This goes super deep and covers a lot of the sort of stuff that we're going to be talking about today, but then actually starts digging into not just sort of like the diagrams about this, but what are the different components that come into play, things like informers, listers, work queues, stuff like that. So it's a really cool deck that goes really deep, and even to the point where I think I'm moving fast here, but like it's like, oh, here's like the references into the Go code and stuff like that for the various things. So like check that out. So like here's client Go reflector, like source code pointers and stuff like that. So a lot of really cool stuff there. Um, so that's cool. And let's see. So we have Amy Amin from Algeria. Good to see you. CPP for Life from San Francisco. Good to see you also. Who is CPP for Life? That rings a bell, but I'm not putting the name to the handle for some reason. Say hi. Okay, and then let's see. So Alex Ellis. So Alex does OpenFaz. I haven't had a chance to play with this yet, but I think this might be a fun episode. Um, it's Dimitri. Okay, good to see you, Dimitri. So a while ago, I was playing around with. Yeah, he hates cap. I heard. That's funny. So Dimitri does the cap stuff. Yeah, which is great. So I did this thing a while ago. GitHub.com, JBeta, ngrok. And this was like, I'm like, hey, how can I adapt ngrok to Kubernetes? And what it ended up doing, and I'm like, oh, I'll write some code. I ended up not writing code. It ended up just being a simple Docker file that did nothing but like run ngrap along with some kubectl run. So it was like, hey, doing like ngrok to be able to get access to service is really interesting. And I kind of left it at that. And for those who aren't familiar, ngrok is this thing that you can run on your laptop that essentially exposes your laptop to the internet. So it's like a security nightmare, but it's also really useful for being able to sort of share stuff off, that's running on your laptop with other people. So it looks like Alex sort of took this and really ran with it and sort of took the idea of ngrok and made it be like a real controller to be able to do things like to be able to do service type equals load balancer in a way where you can expose stuff off your local machine up through the internet. And this is all open source. ngrok isn't, at least the server side isn't. So some really, really cool stuff there that I want to find some time to actually play with. So good job, Alex, on that. Let me say hi to folks. So we have Bargov from BB. What is BB? Ganesh from Delhi and Fully Geared Bear from Portugal. Good to see y'all. Let's see. There's a meet our contributors this week. It's a monthly show. So is this? Okay, this one hasn't started yet. So this is going to be on October 2nd, which is wait. Streamed live. Oh no. Okay, this is the previous one. So there was a lot that happened there, and so Dims was on it. Nikita, Paris, and Kieran. And so Dims, Nikita, and Paris are all now on the steering committee. And so this is a great way to sort of have people share their tips, the ins and outs of what's happening. And then if you're interested in becoming a contributor, check out the Contributor Summit, which is upcoming in San Diego. You can register to that. It's adjacent to KubeCon. And so the Contributor Summit, we have both existing contributors and a track for new contributors. And so if you want to get involved and you're going to be at KubeCon or you're around San Diego, that's a great place to be. Let's see, Nolan, how's it going, Nolan? He's in Indiana. We have Bo in New York, and then Scotty in Dallas, Fort Worth. Good to see you all. All right, so that is sort of a quick roundup. I think there's one other point that I want to make here, and I think anybody who's like been paying attention on Twitter, there was an interesting development around Istio and Knative, and I think if you've been sort of paying attention to a bunch of the sort of inside baseball sort of ups and downs of the cloud native world, there's always been this question of Istio and Knative. Are these things actually going to become part of a foundation, part of the CNCF? What is their relationship to Kubernetes? Because they're parallel projects, released by Google, in some ways really presented to the world as being a sort of companion open source project, set of projects to Kubernetes itself. But they've never been donated to the CNCF. And for years now, there's been a lot of back and forth. Are they going to be donated? Are they not going to be donated? What are Google's intentions about these things? And, this last week, there was a message sent to the Knative developer list, and I've heard through the grapevine that the same thinking is being applied to Istio, where there is no intention from Google at this point to donate these projects to the CNCF or any other foundation. And so it's good that we have clarity there. But I think it really, highlights, in my mind, the difference between open source and open governance. Where open source is that, hey, the source is out there, you can fork it, maybe you can contribute to it, but at the end of the day, there's a single company or single entity that owns the roadmap, the use of the trademark, all the things that actually add up to sort of defining the direction of the project. And Kubernetes is very much open governance, I think, both at the CNCF level, but also at the steering committee level. And I think the fact that we announced the results from our election and as a founder of the project, I'm no longer on it. I think that's a great example of sort of open governance in action. And I think what we're seeing is that there is no open governance for Istio and Knative. Now, what this means practically for folks, I think we're still figuring out what that means. But it is a development, and I know a lot of folks are interested in digesting that. So that's just a little bit of color, a little bit of thinking there. It's definitely been something that has been on folks' minds over the last week. So yeah, and if folks have any questions about that, I'm happy to answer. But it's one of those things I don't think we're going to actually see anything immediately. But and I skipped over one item here. So there's a CVE in the Kubernetes API server. Rory, who's online here, is actually the one who filed this issue. This is a really interesting thing. I'm sorry I skipped over this. So there's this, it's called a billion laughs attack for YAML. Okay, so here's the fascinating thing is that you can take a look at, nice catch, Rory. You can take a look at YAML, and YAML is actually, I think we mostly use it as a plain old data container, maps and lists and stuff like that, essentially a different way of writing JSON. But there's actually other capabilities built into YAML where you can essentially have references that refer to other things. And if you do this, you can have essentially fairly compact text. But if you were to say, hey, evaluate this YAML file as a JSON file and resolve all of those references, this thing ends up getting really, really, really big. And so this is essentially a amplification attack where you can send a small piece of YAML to the API server, and that explodes to a huge amount of memory in RAM as it decodes the thing. And this is in the same vein of you can do the same sort of thing with zip files. So there's what are they called? They're like zip file bomb. That's probably not the right name. It's called zip bomb. Yeah. Similar type of thing where you can have a small zip file, but you can actually go ahead and expand that to a huge thing when you try and actually. So here it's you can have, there's one sample is 42.zip, 42 kilobytes, which expands to 4.5 petabytes, right? So this is the same vein there. And the fact that Kubernetes is actually subject to this is kind of fascinating because most of the tooling, most of the time when people actually deal with Kubernetes, we'll use YAML client side, but then we'll use either JSON or even Proto when talking to the API server. And so it's very, very rare for folks to actually send YAML over the wire to the API server. But for historical reasons, you actually can. You can send YAML to the API server. So I think one of the mitigations that I was saying, hey, let's just turn it off, would be that we could deprecate or remove the ability to send YAML to the API server. But I think there's other places where we're going to look to actually bound the expansion of these things when you upload YAML. But really fascinating, interesting attack. I think it goes to show in some ways that unintended consequences. It's hey, why not accept YAML? Well, here's why not. It's kind of interesting. And so let's see. So Lamati's asking about the CNCF stuff. I'll get to that in a second. Ian Slav says, how the YAML bomb affects server-side apply. Well, server-side apply doesn't send YAML. It's essentially still different ways of actually storing content server-side and then merging it. It's still very much sort of plain old data mechanisms, whether that plain old data be Proto or JSON. We're still not sending YAML over the wire there. And so I don't think that server-side apply is actually intersects with this in any way. But always surprised, right? It's like the security issues always come from a direction that you're not expecting. So this one's actually pretty darn fascinating. So good job, good catch, Rory. And then folks asking about the Istio Knative to the CNCF. Why? I mean, at the end of the day, you have to ask them. I think, I have my own sort of speculations, but I don't want to. I don't want to try and put words in Google's mouth in terms of why they're thinking about this. I will say that the product relationship between Cloud Run and Knative is a pretty strong one, and so I suspect that continuing to keep those things closely aligned is definitely top of mind for them. And losing control might be something that they're worried about, but I'm just speculating, so it's really hard for me to say. And then there's a question also about the CNCF landscape page. There are commercial products, there are non-CNCF open source projects, there are all sorts of things that actually show up on that landscape page. So being on the landscape doesn't mean that you are part of the CNCF, and it doesn't really mean anything in terms of whether you're open governance or not. Yeah, and so I think one of the things, and maybe I'll suggest this to the folks at the CNCF, is that marking which projects we think are open governance might actually be something that's worth highlighting on the landscape page. One of the things that Chris Anasizek, and I'm probably pronouncing his name wrong, who is oh God, what's his official title at the CNCF? One of the things he set up was opengovernance.dev. And if you go here, this is actually a great checklist of sort of what do we mean when we say open governance. And so some good examples here to actually think about. So I think this is an interesting thing to look at, interesting thing to think about. It's an evolution in terms of what we mean by open source communities. Yeah, so he's CTO of the CNCF. Do you think the old Heptio projects are on their way to CNCF open governance? Yeah, we're definitely looking at those. I think for us, as we see a certain amount of traction, it's something that we're going to be looking to expand and take them there if it makes sense. My personal take on this is that it's okay. Oh no, Chris is COO of the CNCF, not CTO. My personal take on this stuff is that it's fine for open source not to be open governance. I think it creates confusion and stress for people when folks bring assumptions or there are implied contracts with your community. And I think anytime when folks change up open source licenses, what it ends up doing is changing the implied contract with your community. And so I think a lot of folks assumed, and I think Google, was definitely not clear early on, that Istio and Knative were on their way towards a foundation with open governance, and it was really going to be a community-driven project. And I think the angst here is really, and folks don't feel bad building their business on top of an open community project, open governance project. I think the angst here is really about changing that contract. And it definitely feels like this announcement of no intention to head to a foundation as a redefinition of the implied contract between the project and their community. So yeah, it's a complicated thing. I don't want to spend the whole hour talking about that. Joy from Richmond, good to see you. Okay, so that is that. Let's see. Okay, so let's dig into what's next. Unless the folks have other things that we want to dig into, I want to get started on doing some live coding and see how far we can get. So the first thing here is that if you go to jbeta.kindcraft, this is an extension of episode 83. At that time, we were using not customized. Shoot, I'm gonna fix some stuff up here. We were using KubeBuilder, sort of a pre-release version of KubeBuilder 2. One of the things I did feverishly in the half hour before this episode is I tried to update the project to KubeBuilder version 2.0.1. And I was 3 seconds away, and I made one mistake with Git here. So I'm going to go through and fix some stuff up. You're going to watch me fumble with Git for a second here. The first thing I want to do is I want to actually change the commit message that I just created. Commit, what was the command to actually edit a commit? So now I'm blanking. I do this stuff all the time, and as soon as I'm doing the live stream, edit commit message, Yeah, commit.amend. Yeah. So git commit dash dash amend. And I always remember that it's 2 dashes, 1 M. I can go ahead and do this. And we can see here, didn't mean customize 2.0. I meant QBuilder 2.0. So I'm going to do that, git push. And it's going to tell me, no, I can't do a git push. But I'm going to do dash F for screw it. You can fill in the gaps there. Is the bottom of the terminal cut off? There we go. Okay, there we go. Is that better? Can you see it now? I actually had another window that let's do that. There we go. Okay. Hopefully you all can see that. I'll make it a little bit bigger too. Wait, why isn't this plus? Okay, probably not that big. There we go. Okay. There we go. We're good. Okay. So I do that. Now, the other thing I did is that the way that I had to upgrade KubeBuilder is what I ended up doing is I ended up creating a new KubeBuilder project and then essentially using the diff features built into VS Code to find places where things were different, find the stuff that actually mattered and copied my code over. As I did that, I missed 2 files. And so I'm going to actually recreate those real quick. I think the easiest thing for me to do is just to recreate those. The first file here is the README. And if I go to the commit in question here, it's the license and the README are the 2 things that I want to actually make sure I get over. I am going to, how can I show? I don't want a rich diff. I want to actually look at the actual. Gar, take me to the file. Copy, no, there. Is it here? View file, there we go. View file, raw, Control A, Control C, or Command A, Control C, V. Okay, so boom, there's that one. And then we're going to do a little hacking here. License. Okay, so now git status, we see those, git commit set recreate license and readme. Okay, git push. Oh, git add. There we go. I know I could have done git checkout head and then blah blah blah, and I always that ends up when it's just a couple of files, I'm just going to copy and paste some stuff. It's easy enough. Okay. So now we're good. Okay, so where we left things off last time, and let's see where we were at. And I think I should be good to go here. I think last time I was working against a cluster that was running in Amazon. Now we're going to be doing it with Kind. So I have kube control get nodes. We're good. This is a brand new Kind thing, and then right before we actually launched things, what I did is I made sure that we could build this. So actually things build. So at least I know they build. And then one of the things that you need to do as part of installing your controller into a new cluster is you need to call make install, which essentially creates the manifests and applies them. And so so I did a make install. We can do that again. This ends up calling customize directly versus using kube control. Kube control -K. And so I had to make sure I had customize installed. Also, the latest version of that, I did that with brew. So there we go. So we got that installed, and now we can do make run. When we do make run, this will actually go through, and this actually ends up generating the controller and then running the thing locally. So this is running locally on my machine. This is a Mac binary. That's using the kubeconfig environment variable that that kube control is using. And then this is talking to my Kind cluster, which is also running on my machine. Because it's Kind, though, it's actually Kubernetes and Docker. It's running with Docker. Docker is running in a VM managed by Docker Desktop. So that's what we have going on here. And so what we have is this thing comes up, and we're starting the controllers are starting workers, and so this is as far as I've gotten as far as testing this thing out. So the next thing we want to do is we want to try and actually create a Minecraft server, and I'm gonna create a new session here, or a new window, and resize this TGI K092. We do that. There we have this. Okay, and the first thing I have to do is there's kind, what is it? It's get kube config path, write that, and then you do kube config equals kube control get nodes. Okay, so now we're actually hooked up to our kind cluster. Maybe. What? Oh, export. Boom. Okay. So now we're hooked up to the we have a new window here. So this one here, we have running our controller in the background. Here we can go through and we have under config CRD, we actually have an example. Is this? No, this is the CRDs themselves. Samples, we have Minecraft. So here's our sample here. So we're going to create a server. This thing's called my server. And we're setting a bunch of stuff in this spec, saying, yes, we agree to the Minecraft EULA. We give the server a name. Which server type do we want? Vanilla versus like the hackable ones like Spigot and all that. And then what users do we want to actually allow to log in and opt and stuff like that. And we can expand this list over time. And I think one of the things I'd love to do is get to the point where we can do things like plugin management and stuff like that using our controller. And so like the end result here, which I think is cool, is that we're going to end up with a Minecraft server API for being able to actually launch and manage Minecraft servers. And we're building that up. So what we can do here is we can go into config, samples, and we do kube control. Well, we can do cap my server cap -a my server -f that YAML. Oh wait, what is a? Isn't it like it's cap deploy, right? And I like cap because it actually shows you what it's going to be doing, and it's like the kindest server here. What's interesting. It doesn't actually list the group. So that'd be interesting at some point. But anyways, it knows that we're going to create this and then wait for it to reconcile. There's nothing to reconcile. It would be interesting if we could have enough metadata and this be something between, metadata that gets reflected through the open API stuff that kind could actually be able to read, so we could actually recognize something as a condition and we actually know when the thing is reconciled. But we're not writing conditions yet, but it's something that we can do. Interesting thing to think about. Anyway, so we have this thing's being created. Now, what should be happening if things work well is that the controller should be doing stuff. What we say here is that it's reconciling and it's trying to create a controller, but then it's running that loop again and again. And as it does, it's trying to recreate the thing. So we have kube control get pods. We have our Minecraft server pod running. Okay, so we at least, we create a CRD that causes the thing to actually create the pod. That's where we left things off last time because we're not doing true reconciliation yet in our controller. So let's take a look at the code and we can actually figure out where we left things off. And let me go through and, can you all read this stuff? Is this big enough to read, or should I make it a little bit bigger? Let's make, that's maybe a little bit too big. But yeah, let's go ahead and see if we can make this work. Okay, so this is one of the things that we actually left off. So let's see, so to do, we have there's some RBAC stuff that we have to deal with, maybe. List out the pods that belong to the server and update the status field. If we already have a server running, then exit out here. And so that's the to-do that we left off, because essentially what we're doing is every time we get called with reconcile, we're going through and we are getting the server, erroring if we're unable to fetch the server. So we're getting the CRD that actually we got triggered on here. And that comes in as part of the namespace namespaced name. So this is actually saying, hey, we're trying to log, and then it tries to fetch that server. If we can't find the thing, then something happened and we'll actually return. And then here's the code that actually constructs a pod and creates it. And so what we need to do is we need to essentially, the next thing we need to do is say if, pod not created already, then, we want to go ahead and do this. Okay, so we have to actually figure out whether the pod has been created already or not. Now, one of the things that we can do to do that is you saw this other to do up here. Where was it? And update the status field. So now the thing that, so the first thing that we're going to do here, let's actually, so what we're going to do is we're going to say get pod status based on this server. So that's the first thing that we want to do is we want to actually look to see like, hey, find me the pods that are based on this server. Now there's two ways that we can do this. And I think this is an interesting sort of way of looking at stuff, is we could have our controller proactively go out and cache all the interesting pods that relate to this particular type of server. That's the first thing that we can do. The second thing that we can do, or we can make a synchronous call to the API server to say, well, get me the pod live. And so as you're building a controller, there's a decision that you need to make in terms of whether you want to use cached values or whether you want to use live values. And I think a lot of times things will be faster and more resilient, and you'll put less load on the server if you use the cache version. Now, one of the things that I want to do here, because I haven't written a lot of code like this in a while, is I want to actually go through the example controller that is part of the KubeBuilder tutorial and just copy code there, because I don't know if I'm smart enough to figure this stuff all out by hand here. So here's what we're doing. We're listing all the active jobs and update the status. So we're gonna copy this pattern here. So what we're gonna actually do is here we have child jobs, but we're actually gonna call this child pods. So that's Kubernetes batch, but this is actually not going to be a Kubernetes batch thing. This is going to be a core.pod list. Okay, so we're going to get a list of pods. That's going to be our child pods. And then we're calling this on R here. So this is the server reconciler. So what is a server? Server reconciler reconciles a server object. And we're calling list on that. The server reconciler is also a client. And so in this case, we're not using a cache. We're making a live call to the API server to actually get this. So that means every time we reconcile, we're getting the freshest possible information about the pods. And so this will actually go through and actually hit the API server on the other side. So here we go. So child pods. Child pods in namespace, matching field, the job owner key. So what is the job owner key? Job owner key is the controller that we're using. Okay, so if we look, so this is Kubernetes API reference. So we're going to look at this. We'll look at 1.15 for safety, because that's what we're actually playing against right now. If we look at, just take like pod, for example, there is, as part of this, there is the standard metadata with a pod. So this is object meta. You can see this ends up being used with every Kubernetes object. One of the things that I think is here, do we have controller? Okay, yeah, so this is meta owner. Okay, so this ends up being me make sure I get this right. I don't want to be confusing things. .metadata.controller is the thing that we're going to actually be looking at. And so this is meta here. It's of kind object reference owner. So this is essentially, and I'm trying to remember the exact syntax here or semantics of this. But this is essentially, there's a way that you can have a Kubernetes object saying, this is the thing that created and owns me. And so let's actually look at our pod and see if we actually have that. So kube control, get pods. We have this thing here, kube control, get pod. And if we look at this pod, we will notice here we have owner reference. And we can say, there's a whole bunch of things that we're actually setting up here as we do this. So one of these things is that this is the name of the, so we have the API version, the kind. So this identifies essentially the type of the object that is the owner. And then this is the name of it. And then there's also a UID. So if things get recreated and stuff like that, we can figure that stuff out. And then what does the controller true actually do? What is that supposed to be? Points to the managing controller. Yeah, interesting. I don't know why it's controller true versus, I wonder when that's false. I'd love to actually understand that. That's not something that I have a deep amount of knowledge on. Okay, and then block owner deletion if true, and if the owner has foreground deletion finalizer, then the owner cannot be deleted from the key value store until its reference is removed. Defaults to false. So this actually is sort of some referential integrity type stuff going on here. All right, so what we're essentially now saying is, just to sort of break all this down to sort of pop a couple different levels, what we're actually saying here, and is that we want to go through and we want to list all of the pods that have an owner reference that point to this particular server object that we're reconciling. And so where did we have, so we had vars here, API, do we have those? Let's see if we actually have some global vars, some constants. Okay, so we'll create some constants here. We at least need this one. We're not going to call this, we're just going to call this owner key. And, okay. Unable to list child pods. And then we return a null result. So if everything goes as planned, afterwards we're going to end up with a pod list that lists all of the pods that were created in response to this particular controller. So that's the thing that we're actually working on. And now, okay, so now, where were we? List all active jobs. So here we go. And now we can actually go through and we can iterate through those jobs and we can actually figure out what's happening here. But what we're going to actually do here is that items is that we're going to actually see like if, so okay, so the first thing, what are some conditions that we want to deal with? What if we have no pods? What if we have too many pods for some reason? What happens if somebody out of band went through and created a pod, assigned it to our controller and didn't do anything? And then we can do like, what if the pod doesn't match our spec? Recreate, something like that, okay? So those are the types of things that we can go ahead and do here. Let's actually save this one for later because this is a harder one, okay? And what we're going to do is we say, what if we have no pods and what if we have too many pods? And so we can go through and we can say, okay. I'm just looking through here. Okay. So what we're going to do here is we can do if child pods dot items is less than 0, or is greater than or equal to, or greater than 1, then delete the extra pods. We'll just go ahead and delete some extra pods because it's like that shouldn't be happening. But this is probably a pretty rare case, so we're not going to sweat it too much. And then we can do also if length of the child pods is less than equals 0. If we don't have any, then that's where we're going to actually go through and actually construct the pod. And here we are, we're just calling create. And we'll log that. Okay. Okay. So we're going to go ahead and do that. I'm going to put a to-do there. We have this. Okay, so now what we're doing is we're actually getting a list of the pods, and if we don't have any pods listed, we're going to go ahead and that's when we're going to create stuff. And so this should eliminate some of the errors that we have going on in our controller. So if we look at our controller now, we have a bunch of stuff happening. So I quit the controller, and then I'm going to actually go through and cube control get pods. And that thing's running. I'm going to do cube control delete pod MC my server. So this will go ahead and delete that pod. And because the controller is not running, it's not going to get recreated. But now what I can do here is if I do make run, what should happen is this controller will wake up. It'll say, hey, look, I have a CRD. Let me go ahead and, oh, something went wrong. Let's figure out what happened. What should happen is that, say I have a CRD. I should have a pod. Let me go ahead and check my pod. And if I don't have a pod, let me go ahead and create one. So it looks like we got a failure. It says, unable to list child pods. Server default my server. Error index with name field. Metadata controller does not exist. So something got messed up here. What am I actually screwing up? Let's actually figure out. That should be looking into the owner reference, but maybe it's different for job than something else. Give me a second here. This is confusing. Object meta, name, link, name, blah, blah, blah. Owner key. Are we setting? Give me a second here. So we're actually constructing the pod. In the meta, we have labels, annotations, name, namespace, a bunch of this stuff. We are going through adding that, doing that. Here we have set controller reference. So this is the helper to be able to do that. Let's actually go look at this code. Go to definition. Yeah, I'm surprised it says metadata controller too. That confused me a little bit. So this is in controller util, set controller reference. Oh, there's a bunch of fun utilities here that we'll be able to use. So we have things like create or update, creates or updates the given object in the Kubernetes cluster. The object desired state should be reconciled with the existing state using the passed in reconcile function. Okay, so we have that setup signal handle. Okay, so we have a few helpers there. Set controller reference sets the owner reference, blah, blah, blah. So that's all good. This is used for garbage collection of the owned object and for reconciling the owner object on changes to own with a watch and queue request for owner. Since only one owner reference can be a controller, it is set. It returns an error if there's another owner reference. Okay. So why is this working here? So this is set controller reference. Do we actually have that? Owner. scheme in order to call some helper set. So we have that. So job owner key, setup, job owner key. So here we can do get controller of, setup with manager, get field indexer. Oh, so maybe, oh, okay, so what's going on here? Setup with manager. So we have a clock that may get passed in. Grab the job. Okay, so we're indexing. So we have an index field. Okay, so we're essentially generating a synthetic field here for this because apparently I'm confused by this. Get field index or index field. So this is in. All right, let's see if we can figure out this stuff. Setup with manager. To do package. What is this? Oh, okay. Make sure they were getting kicked on pod changes also. Yeah. Okay. So this is the stuff that we have to do here to actually make this stuff work. Okay. So let's copy this code here and make sure that this works. Okay, so we have a clock that we're going to set to a real clock if we don't already have one, assuming we have that. And then we're saying manager. Okay, so manager, get field index or index field. And this is, we're doing core.pod, owner key, func raw objects returns a list of strings. Grab the raw thing. So this should be a core.pod. So this is essentially taking the raw object, downcasting it to a core.pod. If it's not, this will actually panic on you. We have this get controller of with meta v1. I'm not sure why we have a squiggle there. Oh, it's just a spell check thing. That's the owner. If the owner is nil, then return that. Make sure that it's a pod. What is the Go modules? I'm going to look at that in a second. I'll look at that. So we have this thing here. Where's our vars, our globals? Okay, so we'll do this. So this is core GV string. So we'll do that. So this is the group version string of this thing. Make sure it's a pod. If so, then we go ahead and we return it. And then we're doing a new controller managed by the manager for the server. It owns core pod and then complete. So that should be, and it's mad. Why is it mad? Don't be mad at me. What is this saying here? Expected declaration found blah. So I have something wrong here. So this, why am I, do I have an extra, oh, I have an extra thing here. Okay. There we go. Okay. So everything, okay. So let's go through and actually look at, so manager, get field indexer returns a field indexer configured with the client, index field. So I believe what's happening here is this is doing essentially client-side indexing, not server-side indexing. So if we go to definition here, and this is in controller runtime, which is sort of a helper library on top of client Go. But the let's see. And so this is interfaces.go on this thing. Controller runtime package client. So this has things like object key from object, patch, reader knows how to read and list Kubernetes objects, writer knows how to create, delete, and update. So these are interfaces, status writer. Indexer function knows how to take an object and turn it into a series of non-namespaced keys. Namespaced objects are automatically given namespace and non-namespace variants, so keys do not need to include the namespace. Field indexer knows how to index over a particular field such that it can later be used by the field selector. Adds an index with the given field. Okay, so we're essentially creating that field there as part of this index. I don't quite understand this. I got to be honest here. This is a little bit of voodoo for me, but I think, oh, I accidentally closed that window. I think I know what's going on. So let's see if we can actually make it work for us. Okay, and then somebody was asking, what is the Go modules? Do you want code to open the external website, Go module support in Visual Studio? It's actually telling us the tools don't provide support for Go modules yet, so you may have a bad time, I think is what it's saying. I think we're just going to have to live with that. Okay. Okay, so let's go through and do a make run again and see what's happening here. Okay, group version not declared by so this is by package v1. Group version, this is some of the stuff that like I don't deal with all the time, so let's look at our example here. This is batch. Batch, when we look at the imports, where's the imports? Batch is tutorial. Oh, this is our, give me a second. So this is not kbatch, this is batch. Okay. Okay, so then this would be, our equivalent here would be Minecraft v1 alpha 1, which should be the thing that we're actually doing here. And so this is why API. And that's the owner. Okay, the owner. We want to make sure. And then the owner should be server. There we go. Hey, can somebody ban the person spamming here? Or I'll go ahead and do that. Let's see. Hide user in this channel. Hide user in this channel. There we go. Okay. Cool. All right. So, okay. So now I think we were actually checking okay, r.clock undefined. Okay, we're not using the clock yet. We don't need the clock, so I'm just going to remove this because we're not doing cron stuff. All right. Okay, so now we got a lot less noise. We're not seeing any errors showing up. So what we're actually seeing here is that we're saying creating pod for server run. And this is actually the name of the pod that we're creating. And then there's a lot of other things that are essentially kicking the reconciler. And so what's happening is that every time the pod changes, we're actually going to go through and actually update. We're going to actually reconcile again because we want to do two-way reconciliation. We want to be able to actually create and modify the pod when server changes, but we also want to actually maybe update the status of server when the pod changes. And so this thing actually will, I think, kick things both ways. So let's go ahead and actually see if we can update the status then as part of this. Oh, the first thing we can do, and this is something that we talked about last time, is if we look at the controller, one of the things that we have here is that we were playing around with this idea of generated name. And so generated name means like, hey, let's not actually sort of name the thing. Let's go through and actually let the name be generated, unique name be generated based on a prefix. And so we're going to call this thing is going to be MC name and then this, and then we're going to turn this into generated name. And we couldn't do this before because we weren't doing full reconciliation. But if we go ahead and do this, is it generated, not generated name, not namespace? Yeah. Does that work? unknown field. Isn't this like generate name, not generated name? Generate name. Okay. Okay, so now, so let's do that as our first thing here. And I'm going to relaunch our controller. And so now we're successfully reconciled. Everything is stable. But now if I do a kube control get pods, I can do kube control delete pod mc my server. That'll delete it. And then what should happen here is that this thing actually should go through and re-reconcile and actually recreate a new pod. This is what should happen. It says pod deleted. Oh, we got an error. We got an error. What happened here? Okay. Okay, so we tried to re-reconcile, and then we got an error, an empty namespace. Oh, you know what? I screwed up as I was editing this stuff. So I'm an idiot. Namespace. Okay, this should be generate name. I merged into the wrong thing. So there we go. Okay, now let's go ahead and rerun this. Okay. Okay. So here we did created pod for server run. And one of the things that you can see here is that now we're actually getting a random name here. And so this is an example of how we have things like when a replica set creates pods and it has a random name. This is one way that you can actually create the random name for the set of pods that you're actually managing. Now we're only creating one pod here for this, so it's not like we could do a deterministic name, but I think it's cool to actually see how the generate name stuff works here. And it's important to recognize that we're reading this out of the result from the create. So what we're actually doing here is we are, if I look, we're going through and constructing the pod, creating it, and then as part of creating it, I believe the pod gets modified with the result from the server. And then you can actually see now we're actually taking the pod there, and the name is actually coming out of it as we're dumping that. So namespace default pod blah blah blah. So that's actually really cool that we see that happening. Let's see how we doing on time. Okay, so let's do a little bit more work here because I think this is fun. The next thing I want to do is let's actually try and write the status back out. Okay. And what we're going to have here is, okay, so the next thing we're going to do is let's decide what we want our status to look like. So we're going to go back to our server type here, and we have spec and status. Right now, if we look at status, we actually have nothing there. But what we're going to actually have is we're going to have, let's do pod name. And we could probably do some sort of official reference thing here, but we'll do string. And then we'll do running Boolean. Okay, so we're going to do a couple of things there. We're going to actually have in the Minecraft server, in the status, we're going to list the actual pod name that we're using, and then we're going to have a bool in terms of whether it's running or not. Now, in real life, and I you know, it's going to be fiddly code, but like we don't, you know, we probably want to have more detailed status here. But this is actually a great way for us to go ahead and get started. And so the first thing we need to do here is figure out get reference append. Wait just a second here. So we have the cron job, failed history, blah, blah, blah. And then where do we actually do the update? Status. Just make sure. To fully update our status, we'll need to list. So where do we actually make the call to update the status here? So here we're going through and we're modifying the actual parent object here. Using the data we gather, we'll update the status of our CRD. Here we go. So here's the call that we're going to do to actually update the status. And I believe this thing actually does a comparison to figure out if anything's changed, because what you don't want to do is actually update the status if nothing's changed. So we're going to go to the server controller here, and then we're going to go through and you know, we're going to do let's do a var pod name string, and we're going to do here, if this succeeds, we're going to do pod name equals pod dot, what is this going to be? Is it get object meta? What would this be? So the pod is, why is this thing not auto-completing for me? This is a core.pod. We can go, you know, go to definition, construct pod, go to, oh, not find all references, stupid thing. This would be, go to type definition, pod, there's a type meta in there. Okay, so this ends up being object meta, which is joined in. And okay, so we can actually open this link here, and this actually takes us, oh no, it doesn't, lame. Oh, if I hover over this, this is name. Okay, so, and this is merged in, it doesn't actually have a, okay. So I can actually just go through pod.name there, and else pod name equals child pods dot items 0, the first one. We'll take that. That's now our pod name. And something weird is going on with YouTube here. There's some sort of like thing going on where it's actually like people are responding to stuff that isn't in our stream. Weird. Okay. Looks like a bug. Okay, so cannot use a variable type v1 as a string value. Oh, items dot name. Okay, so there we go. Okay, and now we can actually go through and we can do MC server dot status dot pod name equals pod name. We can go ahead and do that. MC, and so so now what we have here is we have pod name and pod. We can go, actually let's go through, do var pod. Sorry, just core.pod. There's a lot of, I'm gonna like hide these users that are going through and spamming us here. I think they're responding to somebody else in a weird way. Yeah, there's some weird thing going on there. Okay. Okay, so we're gonna actually, so instead of actually storing the pod name, we're gonna store the pod. And so it's either the pod that we create, which is going to be here. So we're actually good. So we actually don't need to do the assignment here, or we'll actually go through like this. And I think I need to do this equals pod dot name. Okay, and then we can do MC server dot status running, And then, let's see if we go and we look at a pod, and we can look at kube control get pod. Let's see, state running started at ready true. Let's actually just grab ready on that, because I think that's probably container statuses. Phase running. Okay, so if phase is pod dot status, why did it dot is it phase equals pod phase dot running core dot pod running. I think that's what we want there. It's of type pod. Okay, so we're going to set that to that. And then we have to do the update. And we're going to copy the code here to be able to do this. And we're going to do an update context MC server. And then unable to update Minecraft server object status. Okay, so now let's actually see what happens. Fingers crossed. Oh, what happened here? Something's mad. What's it mad about? Encountered struct field pod name without JSON tag. Oh, I didn't put JSON tags on my API. So we have to go back to the types here, and our server types here for our API, and we have to go through and do JSON, and this will be, and we're calling this thing pod name omit empty. Select that, okay? And then we're going to do something similar here. JSON running omit empty. Okay, let's give that a try again. All right, so we got an error here when we're trying to do the update. What's the error? Unable to upgrade Minecraft server status. Server default my server error. The server could not find the requested resource. servers.minecraft.tgik.io my server. So why couldn't it find that? Why couldn't it find it? That's weird. Huh. So it really didn't like that. Update contacts r.status. Oh, so we're updating the status. Okay, so there's so one of the things that I think might be going on here is that with the Kubernetes API server, there's the ability to essentially surgically update status. And so it's actually a sub-resource of your object to be able to update status. And so that way you can actually, using RBAC permissions, give some things permission to update status, but not other things. And I suspect that the problem that we're seeing here is somewhere around updating that status is a problem. And so we want to be able to patch there, and it's not able to actually find it. Schedule time animate. Okay, so what are we actually doing here? So it actually can't find. So we're listing those. Is it Something about main. Do we have to actually go through and actually add something to main? Controller, setup manager. Let's actually check our main and make sure that we actually have the right stuff registered. Controllers with name server, cron job, scheme, manager.getScheme, manager.getClient. Where, okay, so that's slightly different. QBuilder scaffold scheme, do we have that? I am confused. I am very confused. Client go scheme, setup log, scheme runtime, main, old stuff. We have a bunch of. Anybody have any ideas here on why this isn't working? So here we have, we're creating the reconciler, server reconciles, controllers, server reconcile, manager, manager, manager. Okay, so the manager, so we're passing scheme in here in the, before we were doing manager.scheme. Okay, so we can do, that's the same. Setup with manager error equals under, unable to actually create that. Okay, so that's all looking good. So what is the error that we're getting again here? So we're getting, when we're reconciling, we're actually getting something. The server could not find the requested resource. Put servers.minecraft.tgik.io my server. So is it the plural here of servers? Server spec, plural server. So we actually have that there. That should work. I'm very confused. Very confused. What are we doing wrong here? Let's actually not update these things at all. I don't think that's the problem, but we'll give that a try. Pod declared but not used. Okay, so shut up that error. Okay, still getting the same error. Okay, so that's not the problem. Didn't think it was. Okay, so we're doing r.status to status writer.update. What if we just do r.update instead of status? Let's actually see if that works. And then we can figure out what's really going on there. So, okay, that worked. It successfully reconciled it. So it's the status that we're actually having a problem with. And what are we doing? Status.update. Okay, so this is unable to update cron job status. So it's something about using the data getter, we'll update the status of our CR. Just like before, we're going to specifically update the status subresource. We'll use the status part of the client with the update method. The status subresource ignores changes of spec, so it's less likely to conflict with any other updates. Yeah, well, I would. That's the thing is, I was thinking maybe we have to actually pass mcserver.status in there. But what makes me think that that's not the case is that it needs to know the name, right? And if you just pass the mcserver.status, then it won't know the name of the thing to update. So I think it needs the whole object so it actually has the key to work with. You know what? think this might be a bug in KubeBuilder. Or in one of the things with KubeBuilder. Let's look at the releases. Fix. So there's like a... Okay, so we have to declare, maybe this is the thing that we missed. We have to declare that we want the status subresource. Maybe we don't even have a status subresource on our type. So that might be it. Does the make run actually update the CRD, the API server node? Oh, that's probably a good point also. So we probably have to do the make install again too. That's a really good point. Okay, so let's do both of these. Let's go through and make sure that we have the status. The status sub resource is enabled via blah, blah, blah. When enabled, updates to the main resource. So I don't think we did that. Generating CRD. So this would be, this is on, not server spec, server status. Boom. Okay, so we need to actually go through and add that. Okay, and then we're going to do a make install. All right, so now we actually have this. So if we do cube control get this, is that going to work? One of the things that we're going to see is that here's the Open API spec and properties. We see all this stuff showing up there. Status, versions. Oh, I see. Okay, so here is validation sub-resource status. So we actually have a sub-resource actually specified there. I don't think we had that before. So good catch, Mike. Okay, so now let's make sure that we actually, let's go back to our controller. Our controller is calling status. We can do make run. And there we go. Successfully reconciled. Okay, cool. So we probably skipped a step, and this probably was something that is new since the v.2 stuff, or maybe I missed it the first time around because we weren't actually doing it yet. But now if I do cube control get pods, cube control delete pod, mc my server, blah, blah, blah. If I delete that, oh, we errored out. Ah, we hit another bug. What do we hit? What do we hit? Okay, creating pod, and then we actually had a panic. The panic was server controller line 88. What was I doing? If length of child pod items equals 0. Oh, maybe items is null. Okay, so if, what is items? Items is a, maybe child pods, that'd be a pod list. Why would that, invalid memory at no pointer. What? I would have expected to crash up here versus here. What did we do? So we created a pod for server run and served a panic. Server controller, line 88. Let's make sure. Handle crash, panic, reconcile. Time to enter debug mode. Yeah, I mean, like we can start doing delve and stuff like that. I think we might run out of time, but oh, 104. Okay, so that is also showing up. Okay, so here we're doing pod.name. And so something happened. Oh, you know what? This got shadowed. Freaking A. This is, okay, this is like my least favorite thing about Go right here, okay? So what happened here is I declared pod here, and then I declare a new pod with the colon equal. This actually creates another variable that actually shadows this variable. And so that means that this thing stays null as we actually go through this line. So what I have to actually do is we have to do var error. We do that, we do this. Now we're actually not creating a shadowed variable. and it'll actually set this particular pod here that will then be used down here. So this is the problem that we had. So now let's go through, and that is the worst. The whole shadow thing, that should be an error. Like if you actually have, if you create a new variable in a subscope using the colon equal and it actually shadows the variable above. Actually, you know what the syntax that I think we should have is that you should have the colon next to the thing that you're creating. So it should be like error colon and then pod colon says actually create a new one of each of those things so that you can actually explicitly say which of the things on the left you think are new variables, not old variables. But, you know, too late now. So now, okay, so now we're going to do cube control, delete pod, this thing here. It takes it a second to delete it. Okay, boom, we reconcile it. Okay, so we got another error. Okay, and so what happened here is, this is fascinating. Okay, so successfully reconciled, and then some sort of concurrency happened here. So we created the pod, and then it's like, oh, I'm unable to update this. Operation cannot be fulfilled on servers Minecraft TGI my server. The object has been modified. Please apply your changes to the latest version and try again. So something behind the scenes, actually updated the status. So we actually had two status updates that conflicted, but then things actually ran again, and eventually the whole thing sort of settles out. And I'm not sure exactly why it happened like that. But if we do cube control get server, if I go ahead and look at this, you can see we do actually have the pod name and it's running. So we're actually up and running. Oh, you know what happened here? I'll tell you what happened. Is that the race conditions, it's beautiful. Okay, but this is actually the sort of stable, like this, I mean, understanding what's going to go here, and I'll explain it, is actually, like, if you understand how this works, you understand sort of the fundamental stability of Kubernetes, where things actually just sort of like work themselves out. So what happened here is that we created a new pod, okay? So we created a new pod. Now, what happens is we're actually watching for those new pods getting created, and every time that new pod gets created, it goes through and we're going to do another reconcile loop. And so we created a new pod here, and because of that, we actually got an update for when the pod got created, and that created in, so we actually had two reconciles going on at the same time. And the pod creation reconcile actually won the race, or like one of them won the race to be able to update the status. And then the next one tried to update the status, and it's like, hey, two things tried to update the status and they actually gave conflicting information. I'm going to ignore it, but the latest one should actually go through and win over time. And so the idea is that you keep retrying until this stuff actually works. Now, I think there may still be some races here if I'm thinking correctly, because when I actually go through, okay. So what happens is, and this is the way that this higher level framework works. If you end up returning an error from the reconcile, then it'll actually enqueue it to rerun reconcile in the future. So we're going to go to let's see. So reconcile. If we go through and let me actually make sure. So this is server reconciler. Okay, this is actually implementing so the manager thing actually is the one that does that. Okay, so if we actually look at manager and we go to type definition of this thing, what we can see is that here's a bunch of things on the manager. If we look at reconcile, this is manager package. We're going to look at controller, maybe this. Controller implements the Kubernetes API. it's a reconciler. We want to go to the reconciler is the thing that we're going to look at. Go to type definition. And this is all part of the controller runtime helper library. Reconcile. Reconciler performs a full reconciliation for an object referred to by the request. The controller will requeue the request to be processed again if the error is non-nil or if result requeue is true. Otherwise, upon completion, we'll remove the work from the queue. And so what happens is that like there was some race condition. We went to write stuff in. We got an error saying, hey, retry later. And because we return that error up to the manager will actually go through and requeue this thing to actually retry it. And so that means that as long as we're returning an error, reconcile will continually be called until things actually settle down. And that ability to be able to deal with, it's like an optimistic concurrency. Like we try and make sure that we do a lot of things at once. If they work out, they work out. If they don't work out, then we essentially re-reconcile and eventually things actually settle down. Okay, when I was playing around with controller runtime, default concurrency was set to 1. Not sure if KubeBuilder actually modifies that. That's actually an interesting question because like the only way I could think this would happen is if we actually do have some concurrency happening. It may be, it may be concurrency. Where am I at? Okay, so let's look at main here because that's probably where we would set it. Or I wonder where it's actually set. So this is controller runtime concur. We'll actually see what's happening here. Max concur is the maximum number of concurrent reconciles which can be run defaults to 1. You're right. Huh. Controller dot option. So we have a new manager. Get configure die. Where does it go to definition? Where is this coming from? It returns a rest. No, that's just the config for. Oh, I lost main. Controller.option, scheme metrics, leader election, enable leader election, and all that. Do I actually have 2 of them running at once or something like that? We have the logger, we have that. Enable leader election is set to false. All right, let's look at makefile. When I do a run, what are we actually running the thing with? Go run. It's just plain, we're not setting any options with the thing. All right, what is going on here? Why are we getting that concurrency error? Let me think. Something is updating the status behind there. So, okay, so one of the things that we can do here, let's actually go through and, okay, here's how we're gonna debug this. And so like a lot of times you really understand stuff because you see like, hey, this is probably fine. This will probably work out. I'm pretty sure that, there's no serious bug here. But like really root causing and understanding it, this is how you really test your understanding and know what's going on. So I'm gonna do a kube control get, we're gonna do this, okay? But what we can do here is we can give it a -w. And if we give it a -w, that means that we're gonna get notified every time this thing gets updated, okay? And so now we have our controller here. Okay, now I'm gonna run the controller in the background. Now I'm gonna do kube control, delete pod. Okay, we're gonna delete that pod, and we're gonna see what the updates look like. Okay, so it looks like we got 2 updates as far as I could tell. The first update, and unfortunately it doesn't actually sort of put any dividers between stuff, but this is the first update here, and you can see we set the pod name in. And yeah, so we got 2 updates that actually were successful. The first one actually went through and actually set the pod name into the status. And then the second one went through and actually set running equals true with this thing. Now, along the way, was there actually other metadata that got set on this? We have a bunch of the cap stuff that is like the original stuff. We have the creation timestamp, the generation. We only had, well, the generation is 2 here because we just updated the sub resource of the status. We have resource version 10.5.3.2, 10.5.5.2.1. That's global across all of etcd, that number. It's an incrementing counter, but you're not supposed to actually look into it. Self-link, the UID. So I didn't see any other changes out of band. Let's see. Oh, and this time we didn't get any error, so we actually didn't hit the race condition that time. Inislav saying, when you send the data to the API server and setting some metadata. So yeah, so that may be that. Dimitri, I wonder if cached in mem resources aren't being updated for some reason, but you are doing a get at the beginning of the reconcile. Yeah, so we're not actually pulling anything out of an informer cache, I don't think. Isn't it the case that you are not overlaying the pod from the read state, i.e. the object is going to be different and hence causing the update to fail? Well, I'm not updating the pod, I'm updating the server object. And I believe so when we actually look at our controller here, one of the things that we see, and what was I modifying? What? I have no idea what got modified there. Sorry, I'm doing stuff here. Maybe that works, maybe it doesn't. Okay, so we're doing, so pod is either going to be, as we go through here, pod is either going to be the one that we create, in which case I believe create actually updates pod based on the result from the server. And so if I go through and if I do go to definition of this, create saves the object in the Kubernetes cluster. Okay, that's not useful. But I believe it actually gives you an updated version of the object. I believe that's what happens there. I could be wrong. But we do know that after we ran this, the log actually had the updated name. So we at least got some information back. And so that was enough of a name to be able to put in here. And then we actually can see if it's running. And so it worked last time where we didn't get the race. We didn't get any errors this time. Okay, so let's run this again one more time. And we're going to delete it again. Okay, there we have the pod. Oh, we had two pods? What happened there? LD4S. Oh, wow. Oh, okay, that's fascinating. Okay, I see what happened. Okay, so this is interesting. So we got one update as the pod that we were deleting went from running to not running. We actually went through and we actually removed the running Boolean from this, right? And so this is as we were deleting. And we did a status update for that. And then we ran another reconcile to be able to actually, when we started the new pod, to be able to actually do status equals that for the new pod. So we actually removed the old pod, did the, changed the status, and then we actually saw that thing go to running. So we actually saw a sensible set of updates to actually come through. But we got some errors here in terms of, again, operation cannot be fulfilled on servers. The object has been modified. So I have to think that we have some sort of concurrency going on here. Even though we have the reconciler set to actually not do any sort of concurrency. I'm very confused. Okay, wait until jitter function controller worker process next work item. Yeah, I'm really confused on what's going on here. Either we have some concurrency or we have some stale stuff in the work queue. One of those is actually happening. Okay, so we have max concurrency, maximum number of reconciles that can be run, and this is on a manager. So this is in main. Is it? No. Yeah, new manager. Options. No, wait, no. This is in server controller. Server reconciler. Okay, where do we actually configure that? Is that in main? Okay, server reconciler. We create that. We have that set up with manager. Go to definition of setup with manager. Setup with manager is in server controller. And here's where we actually do the index field. New controller managed by for this about complete R. Server reconciler. Okay, so I'm running out of time here because I got a meeting at 3. I gotta think, so like either we have stale information in the queue or we're actually getting some concurrency even though we don't think we're getting concurrency. And so one of those is happening here. I would love to actually dig into the manager here and actually let's just read some code here. I'm going to go to definition of this thing here. A manager is a manager.manager. Go to definition. This is an interface. Set fields, get config, get scheme, get client. There's a lot going on here. I see we had to sleep and see if the issue goes away. Exactly. Well, I don't think it's an issue because I think it settles down. So we're not actually in, I'm not worried about us actually having real problems here. I think the thing is sound. I just don't feel like it breaks my mental model of what's going on. And I think, as you're programming, I'm the type of programmer where I want to actually really make sure that I understand what my mental model is for this stuff. And so we have manager, internal. So, and I think that's the problem that I have here. Reconcile. So where is the thing that's actually, so the manager, sync period. So that's not the thing that we're actually calling. Okay, so we're calling, so it breaks my mental model, and that's why I'm having a new controller managed by, oh, this is in controller. Okay, so go to definition, builder, go to definition. Oh, I love the love in the comments. It's wonderful. Okay, so we have the builder here. Builder is, so what is this package here? Does it have, okay, package builder provides, wraps other controller runtime libraries and it exposes simple patterns for building common controllers. Okay, so this essentially sort of sets up the reconciler stuff. Controller, for type, API, blah, blah, blah. Okay. Complete with the reconciler builder build R. Must provide a non. So we have a manager, a reconciler. Set the controller managed by. We do a watch. And queue request for object. All right, I'm gonna have to like watch all the managed types, do the watch requests. Load. I'm gonna have to dig into this to really understand what's happening. I don't think we're gonna have time here. So we have controller options, new controller, and we have this is concur. Where's the concurrency stuff used? I feel like it's the controller options. New controller. Okay, go to definition. New controller, controller.new. Max concurrent reconciles equals 1. New. Controller. So it could be that there's like a bug here. Okay, so this actually does a go, wait until worker runs a worker thread that just dequeues the item, processes them. And so it's actually going to run that. Yeah. I don't know. Process next work items. This is just the main old, this is controller runtime. This is the worker queue. Process next work item, gets it out of the queue, runs it. Okay, so what's going on here? Yeah. All right, well, I'm out of time now, unfortunately. You know, this is not a satisfying like place to stop for any of us. What I'm gonna do is I'm gonna check this stuff in. It's going to be an up-to-date thing. I think we made some real progress because we have a real reconcile loop now. I think for me, the next step is like, let's actually go through and update our README so we can keep track of stuff. Populate status. Okay, we're doing that. Boom. We'll go through and like, can we do like a squiggle? Does this work? I don't know if GitHub Markdown supports that. Recreate pod. We haven't done that. Okay, so we haven't done a lot, but we're populating the status and we're doing true reconciliation now. I think, next time if I were going to do this, I want to do something a little bit more fun. I want to get to the point where I can actually go through and create and manage the service to this so that I can actually get into that. And then I think part of the status that we'll want to do is we'll want to manage that, hey, this thing creates both the service and the pod. Let's actually reflect both of those into the status and maybe actually populate that with the IP address and an address that we can connect to Minecraft to actually be able to do that. So I'm going to actually say the service thing is going to be sort of the next thing that I want to do here. So let's go ahead and do that. Git status, git commit sam, update after TGIK 092, and we're off to the races. Fernand says, could you try another read with a reflect deep equal and see what changed prior updating the status? Yeah, that might be worthwhile to actually go through and do that to try and debug it, because clearly like it thinks there's a diff there. I think we're out of time. Yeah, I think next time like we'll either pick up on debugging this, or I think maybe we can go through and try and resolve it otherwise and sort of give you all the answer. But if folks do have an answer, feel free to send some PRs to my to the GitHub repo, and we can actually start from there. I'll try and keep an eye on that, and hopefully we can figure out this mystery. And next time we start, we'll pick up and we'll do the service stuff so that we can actually connect to the thing. So that'll be a lot of fun. So all right, thank you everybody for joining in, and hopefully we all learned something. It's a different flavor of TGIK when I'm doing the coding here, so hopefully you enjoy that. Let me know what you think, and I will see you I'm going to be at a conference next week, so I'll see you in a couple of weeks probably. All right, talk to you all later. Thanks for joining in.